Hello, how are you doing? This is Mike again, and we are back in the second part of our absolute value inequality solving series. So before we talked about how to solve an absolute value when it's set less than or less than equal to a constant k, and we said that that was negative k was less than x, which is less than positive k. And again, this applies, so I guess if we want to split this up into two different equations, we could say that this applies for less than or equal to, and we're going to say that negative k is less than or equal to x, which will be less than or equal to positive k. So now what we're going to talk about is when we have a situation where we are greater than k, so when we're greater than a value of k. So let us go ahead and look at this other scenario of when we have the absolute value of x is greater than k. And this also is going to apply to greater than or equal to, but for right now I'll split them up and we'll see the two different forms. But again, for right now, let's go ahead and talk about k being greater than or equal to 0. So we're going to keep this a little bit easier right now and say that k must be greater than or equal to 0 because this is a little bit more difficult to solve if we have a negative constant. What this means, this will imply that x must be greater than k, x must be greater than k, or x must be less than negative k. So we'll keep the sign, keep the constant, then we're going to flip the sign and flip the constant. So this also applies, I guess we could look at this as a fourth form of the absolute value of x is greater than or equal to positive k, and again this is k being set greater than or equal to 0. So this implies that x must be greater than or equal to k, and again I'll make sure to denote that we will have or x must be less than or equal to negative k. So we're going to flip and change our signs. I'm getting rid of those little lines underneath because I don't want that to be confused with greater than or equal to or less than or equal to. So I got rid of those little lines there. So we're going to have two scenarios here of a greater than or equal to. However, it's the same form. We just have to change the sign. So let's go ahead and apply this. Let's go ahead and apply this to an example. Let us apply this to an example. So applying this to an example, we're going to have to, let's go ahead and solve, and again this will be to solve. The absolute value of x is greater than or equal to positive 4. Okay, so remember, if we have the absolute value of x is greater than or equal to a constant k, this implies that x is greater than or equal to k, or x is less than or equal to negative k. And I like to write these things out every time I do a problem to make sure that I don't forget the solution or forget the form on my way. I don't want to forget anything. So how does this work? We're going to say that x must be greater than or equal to positive 4, or x, we're going to flip the sign to less than or equal to, and then flip the constant to a negative 4. When we solve this, let's go ahead and graph these on a number line. So I'm going to graph this first one. Actually, I'm going to change the colors to make it a little bit more visible. And then I'm going to have, let's say we'll have green here to be x is less than or equal to negative 4. That's definitely a very sharp and bright green. So let's go ahead. I'm going to put my 0. I'm going to put my positive 4 here. So x must be greater than or equal to 4. So I'm going to put a bracket opening to my right at that value. And then here at negative 4, I'm going to put a bracket opening to my left, and that should be intersecting this point, and that's going to point out to the left. So if I want to write my solution in interval notation, I'm going to start by where my arrow reads, and notice my arrow reads all the way over down here. This is negative infinity. So I start out reading left to right, so I start at negative infinity, and I go all the way until negative 4, and I'm going to close negative infinity with a parenthesis, and then I close negative 4 with a bracket because we are working with greater than or equal to. And then notice my sign states or, which stands for or is symbolized by the term u, which is a union symbol. And then I start at 4 again, and then I go all the way out to positive infinity. And we're going to always close our positive infinity with a parentheses and then close our 4 with a bracket because we are working with less than or equal to. So here we're going to have a little bit more of a not saying a more difficult understanding, but it's going to take a little bit more work for us to decipher our solution. And I always recommend using a number line. If we want to write our solution in set notation, we're going to write this as the set of x such that x must be less than or equal to negative 4 union x must be greater than or equal to positive 4. So that's how we're going to write that as set notation. So there's two different notations. I tend to like interval notation with this solution, with this type of question, but again, that's just my preference. Depending upon your instructor or faculty member, you're going to have to determine whether or not they want interval notation or set notation. If it was me, I don't care as long as you are correct with the notation. You can't combine the two notations. So, so as long as you are correct, that's all that matters with me. So let's go ahead and try another example. Let's try another example. And this other example will state to solve as well. So we're going to solve. Let us try the absolute value of 2x minus 1 plus 3 is greater than 7. Let's say 6. Let's say 6. Greater than 6. So the first thing that I'm going to do is that I have to isolate the radical because we only know the rule for the absolute value of some value x is greater than or equal to some constant k. Whoops, I don't know what I just did there. So let me go back down. Greater than or equal to some constant k. So we're going to go ahead and subtract 3 on both sides. And we get the absolute value of 2x minus 1 is greater than positive 3 because the negative 3 and the positive 3 cancel in the middle, and 6 minus 3 is a value of 3. So what does that imply? That implies two different inequalities. This implies that 2x minus 1 is greater than 3. So I rewrite exactly what we have. We keep the sign, keep the constant, or we flip the sign and flip the constant. 2x minus 1 is less than negative 3. So we either flip the sign and flip the constant, or keep the sign or keep the constant. That's the way that I'd like to remember it. It's sort of maybe some saying that I use to remember this. Solving each one of these separately, we're going to add 2. We're going to add 1 on both sides. Add 1 on both sides here. So we get 2x is greater than 4, and we're going to divide both sides by 2, and we're going to get x is greater than 2. And here we're going to add 1 on both sides. And we get 2x here, the negative 1, the positive 1 cancels, is going to be less than negative 2. And then we're going to divide both sides by 2. And we get x is less than negative 1. So I'm going to go ahead and we'll go ahead and use our colors again. So I'll use this blue. I'll rewrite this one in blue. X is greater than 2. And I'll write this one in that green color, this piercing green. So, so now we have our two solutions. Let's go ahead and write these on a number line so we can identify how to write them as an interval and set notation. So on our number line here, we're going to have our critical point 0. Everything's going to be based off 0. So we have 2 here, and we're going to have a parenthesis opening to my right. So if you have to graph these on a number line, you're going to graph using a parenthesis because we only have a greater than sign. So now here with the x must be less than negative 1, we have our critical value of negative 1, and this will get a parenthesis opening to the left, and then our arrow will continue on to negative infinity. Writing this solution in interval notation, we're going to start out by where we see our arrow on our left side, which means we're going to start at negative infinity until negative 1, and we're going to enclose both of these with parentheses. We always enclose infinity and negative infinity with a parenthesis, and then we're going to enclose our negative 1 with a parenthesis because we're working with a less than sign. And notice here, our instructions state or. Or is symbolic with the mathematical term u. And then we're going to start again at 2 and go all the way to positive infinity. 2 will be enclosed with a parenthesis, and infinity gets enclosed with a parenthesis as well. If we want to write these in set notation, we are going to write the set of x such that x must be, so we're just going to write just what we see, x must be less than negative 1, which comes from right up here. And then we're going to combine that with a union symbol. Then we write our second constraint that x must be greater than 2. And then we're going to close off our brackets.